Hi, it's Grace again, and today we're on lesson 6. Today we're going to be covering printing sequences in Java. So let's get started. So the first thing we're going to do is write a program that prints out the first n terms of an arithmetic sequence. So before we do this, let's go to replit.com, sign in, and set everything up. Press the blue create button on the sidebar once again, Java template, and let's title this lesson 6 and create. Now, once you've done that, make sure you set up the scanner so that we can read in our input. Okay, so now we're good to go, and let's figure out how we can do this. So we want to print out the first n terms of an arithmetic sequence. So an arithmetic sequence, for those who do not know what it means, I'll provide an example. So say we have the sequence 3, 6, 9, 12, and so on. Now, this is an arithmetic sequence since we have a common difference of 3 between every 2 consecutive terms. So between 3 and 6, the difference is 3. Between 6 and 9, the difference is 3. Between 9 and 12, the difference is 3. And that should continue so on for every other pair of consecutive terms. Now, when we define an arithmetic sequence, we say that the term an, which means the nth term, is equal to the first term, our initial term, which I'll call a, plus this difference, the common difference, which in this case is 3, and I'll call it d, times n minus 1. Now take a few seconds yourself to verify this. So our first term here is 3, our second term is 6, our third is 9, and our fourth is 12. So just take a few seconds to verify that yourself. Okay, so we have the formula figured out and we understand the math. So all we have to do is implement this in Java. So for our input, it would make sense to read in the initial term a and the common difference d and n, the number of terms that we want to print out. So let's go ahead and do that. Let's first create the variable a, an integer, and read in its value. And then let's read in integer d, the common difference. And then finally, let's read in n, which is the number of terms that we want to print out. Okay, so basically now we want to print out n terms. Now let's think, what could we use that would help us do that? So obviously we don't want to write n separate statements. Firstly, because that can be inefficient, and secondly, because we don't know what n can be. So we're going to use a for loop to print out these terms. And this for loop should run n times. Okay, now, so there are actually two methods that we can solve this problem. So I'm going to explain the first method. For the first method, we can simply calculate the ith term. So let me create a variable called a underscore n for the nth term. Oh, sorry. It will be called a underscore I for the ith term. And so how do we calculate this? Well, first, we take our initial term, and then we add d times I. Now, you may be looking at this and thinking that it doesn't exactly look like the formula that we have right here. This one says a plus d times n minus 1, and in this case, I replaces our n. Well, here we have a plus d times I. Now, why is that? This is because we start I at 0. If we take a look here at this sequence using the formula, we first find that a1 is equal to a plus d times 1 minus 1. And this evaluates to a plus d times 0, right? And this is what we get for ai in the first iteration of our for loop, where I is equal to 0. Now for a2, we would get a plus d times 2 minus 1. And this simplifies to a plus d times 1. And that will be our next iteration of the for loop. We increment I, so we have I equals 1, and then int ai equals a plus d times 1. Now, if you really found that confusing, you can obviously change the for loop a little bit. You can have I equals 1, and then allow it to run as long as I is less than or equal to n, and then multiply d by I minus 1. That also works. Okay, so now we calculated the ith term in the arithmetic sequence. All we have to do is print it out. And there we go, we're done. That's pretty simple. So let's run this, and then I will go over the second method. So I'm gonna let my first term be 3, the common difference be 3, and I want to print out 4 terms. Now here's our output. We get 3, 6, 9, 12, which is correct. This is the example I just used. Now, let's go over the second method. And I'm going to comment out this for loop here. Okay, for our second method, we're still going to use a for loop, and we're still going to let it run n times. Okay, so this time, rather than calculating the ith term and creating an entirely new variable, as we did in line 11, we're instead going to print out our variable a and also update it. So first we'll print out a, and this is our ith term. But then recall that this is an arithmetic sequence, so we need to add on the common difference to get to the next term. So we increment a by d. So how will this look? When I equals 0, we'll first print a, which is 3. And then we update a by adding the common difference, which is 3. So a becomes 6. And then we go to the next iteration, I equals 1. We print out a, which is 9. Oh no, sorry, we print out a, which is 6. And then we increment a by d, and we get a equals 9. And so on until we reach the fourth term. So now let's run this. I'm going to use the same numbers. So a equals 3, d equals 3, and n equals 4. And we get the exact same sequence, 3, 6, 9, 12. Okay, so you've learned 2 different methods to do this. One where we create a new variable and calculate the ith term at each iteration, and another one where we just simply update one variable. Now, I would personally prefer the second method since it takes a lot less computation. But either of these work fine. Okay, so now let's write a program that prints out the first n terms of a geometric sequence. Now, for anybody who is not familiar with a geometric sequence, I'll explain it really quickly with an example. So let's say I have the geometric sequence 2, 6, 18, 54, and so on. Okay, and this is a geometric sequence because between every 2 consecutive terms, we have a common ratio, which is 3. So you notice that 2 times 3 equals 6. 6 times 3 equals 18. 18 times 3 equals 54. And so on for every other pair of consecutive terms. So how we express a geometric sequence? Let's say the nth term, gn, the nth term of the geometric sequence, equals to a, the initial term. Here, I'll label it. In this case, our a is 2. Equals a times r to the power of n minus 1. So take a few seconds yourself to verify that. Okay, so once again, we have an explicit formula. So let's use this first. But first of all, we need to read in some input. So once again, we're going to read in the initial term, A. And then we're going to read in our common ratio, R. And then we read in N, the number of terms that we want to print out. Okay, so similar to the arithmetic sequence, we can use a for loop to print these N terms out. So it's going to run N times. Now, in each iteration of the for loop, let's create a variable called gi, and we're going to calculate our ith term of the geometric sequence. So using this formula, it would be a times r to the power of I. And you may be asking, why is it not a times r to the power of I minus 1? Well, same thing as the arithmetic sequence. Because we start I at 0, we don't need to subtract the 1. We're already at I minus 1, technically, each time. So, for instance, when I equals 0, then our gi is equal to a times r to the power of 0. Now, this is our first term. And our first term, g1, is also actually equal to a times r to 1 minus 1, which is a times r to the power of 0. So it's the same thing. So you may be wondering now, how do we express powers in Java? There is a handy function that we can use for this, and it's called math.pow, which is short for power. So it takes in two numbers. The first number is the base, and the second number is the power. So in this case, we're taking r to the power of I. And this function, math.pow, returns a double. So we want to typecast it to an integer. Since remember that our variable here, gi, is an integer. We cannot have an integer be equal to an integer times a double. Those operations don't work because you remember that in Java, we can only perform operations on variables of the same type. And now all we have to do is print out gi. Okay, let's run this. And I will use the example that I just shared. So a equals 2, r equals 3, and n equals 4. And here we go. Here's our output. 2, 6, 18, 54. Now let's go over the second method. And it's similar to the second method for calculating the arithmetic sequence terms. rather than calculating a new variable each time, we simply update the variable a and print it out. So once again, we let this for loop run for n times. Then we print out a. And then we multiply a by the common ratio to get to the next term. And we are done. So let's run this. I'll use the same example. A equals 2, R equals 3, and N equals 4. We get the exact same output, 2, 6, 18, 54. So you start to notice some patterns now. We can, usually for these kind of problems, you have several options. The first one, you can calculate the term at each iteration, or you can keep updating it and then print it. Of course, the latter requires less computational work, so I would still prefer it. Now, let's write a program that prints out the first n terms of the Fibonacci sequence. Now, for anybody who is not familiar with the Fibonacci sequence, let me explain it really quickly. So the Fibonacci sequence looks like this. And I will just write out the first few terms. So 1, 1, 2, 3, 5, 8, 13, 21, and so on. So in the Fibonacci sequence, each term is equal to the sum of the previous two terms. So for instance, 2 is the sum of its previous two terms, 1 and 1. And then 3 is the sum of 2 and 1, 5 is the sum of 3 and 2, 8 is the sum of 5 and 3, and so on. So how can we express this formula-wise? Formula-wise, it would look like this. We would say Fn, so the nth term of the Fibonacci sequence, equals Fn minus 1, so the previous term, plus Fn minus 2, which is the term before the previous term. So for instance, if I wanted to find F4, this is equal to F3 plus F2. And we find that the third and second term are 2 and 3. So F4 is, oh no, sorry. The third and second term are 2 and 1. So F3 equals 3. Okay, so the first thing we should do is read in n. the number of terms that we want to print out. Now, you'll notice one thing. Say we want to find F1. Well, based on our formula, we would be finding F0 plus F negative 1, which is total nonsense. We don't have a negative term at the sequence. So what do? We declare variables for the first two terms. F1 equals 1, F2 equals 1. And then we declare one more variable, F3, which is going to be basically our current Fibonacci term. Now we set up a for loop to run this n times. Now this time I'm going to let it run from 1 to n to make it easier to understand, since I corresponds to the ith term. So term 1, 2, 3, 4, 5, and so on. So we already know that if we're calculating F1 or even F2, we're going to get an error. So we first check if we're trying to calculate the first or second term. If we are, we can just print out the answer. We already know it. Okay, now if we're not calculating the first or second term, we have to do the work ourselves. So recall that F3 is going to be our current term. So how I'm going to calculate it is F3 equals F1 plus F2. Now, how does this logic work? Let's go to our Fibonacci sequence over here. So we already know F1 starts at 1, F2 starts at 2. Okay, so we have printed out 1 and 1 already. Now we want to calculate the third term. And this is going to be our F3, right? And our F3 equals to the sum of the previous two terms, which are F1 and F2. And basically, these two variables are going to store our previous two Fibonacci terms. So we've done the calculation. And then we print it out. Okay, but we are not done yet. We want to update the previous two terms, which are F1 and F2. So in our next iteration, we'll be calculating the fourth term, which is 3. And let me cross this out. So the fourth term becomes our F3. And then 1 becomes our F1, and 2 becomes our F2. Now, do you notice something? F1 will have the same value as f2 in this iteration. Let me just specify which iteration we're on. So here we were on I equals 3, and here we're on I equals 4. So we shift our f1 and f2 from the previous iteration by one step. So our f1 takes on the value of f2, and our f2 takes on the value of f3. And then we calculate a totally new f3, which is the fourth term. So if we're to write these, we would be assigning the value of f2 to f1, and then we'll be assigning the value of f3 to f2. And then we are done. We let this run for n times, so we print out n terms. Let's run this and see if it works. So let's say I want to print out 7 terms. Now what do we have? So we have 1, 1, 2, 3, 5, 8, 13, which is correct. Those are the first 7 terms of the Fibonacci sequence. Let's try a larger n. Let's say I want to print out 12 terms. So we left off at 13, I believe. So 13 plus 8, 21, then 34, 55, 89, 144. You can also do the quick math to confirm that this is correct for yourself. Okay, so you've successfully written a program that can print out the first n terms of the Fibonacci sequence. So let's move on to our very last exercise. And this is rather similar to the Fibonacci. So in this exercise, let's write a program that prints out the first n terms of the Pell series. I think most people would be unfamiliar with it. So let me explain it. It's very, very simple. This is the Pell series. We have 0, 1, 2, 5, 12, 29, 70, and so on. Now, it's a lot harder to detect a pattern with this series compared to the Fibonacci, so I'm just going to provide the explicit formula for you, and all we have to do is implement it. So we say that the nth term of the Pell series is 2 times p n minus 1 plus p n minus 2. Now, this formula looks awfully similar to the Fibonacci series, with the only difference being that we multiply the previous term by 2. So this is easy to implement. Let's go to Replit and do that. All right, once again, we are going to declare 3 variables, 2 for the first 2 terms, and the third one for our current term. So P1 equals 0, P2 equals 1, and P3 shall be our current term that we're calculating. And once again, we run this for loop n times. So we first check if I equals 1, because if I equals 1, then our formula would look like this. P1 equals 2 times P0 plus P minus 1, which is nonsense. So we check if we're calculating the first term. If we are, we can print out the term because we already know its value, which is 0. Then we also check if we're calculating the second term. Because if we're calculating P2, our formula looks like this. 2 times P1 plus P0. We don't have a P0, so once again, that will not work. We write an else if statement to check if I equals 2. If it is, we print out 1, since we already know that's the second term. Okay, now for our else statement. We are past the first and second term, so we have to do some calculation work. P3 is going to be our current term. And how do we calculate that? We calculate that by taking 2 times P2 plus P1. P2 is our Pn minus 1 term, and P1 is our Pn minus 2 term. And we do a similar thing where we shift P1 and P2, which are our previous two terms. So P1 becomes our P2, and P2's value becomes that of P3. And that's all there is to it. We are done. So let's run this. Let me print out the first 7 terms. Oh no, I totally forgot to add. We need to print out P3, our current term, else we're not doing what the problem asks for. Okay. First 7 terms, 0, 1, 2, 5, 12, 29, 70, which is exactly what I have here. So we are done with our last exercise. Now, thank you so much for watching this lesson, and I will see you guys next time. Bye!